Hello, everyone. Good morning. Um, my name is Hamid Akhtar, and I'm part of Percona's Postgres engineering team. Today, I'm going to discuss about Postgres high availability considerations and candidates. So it's more like an intro level talk about how and what kind of considerations and requirement assessments you do before setting up a high availability setup. A bit more about myself. So more than 2 decades of professional software development experience. I've recently joined, just over a year ago, I've joined Percona. And prior to that, I've been part of Hygo, which is a Postgres company, and Enterprise DB, where one of the core focus of my team was building the official Postgres installers. So the one-click installers that you may have used on Windows and Mac, and previously on Linux and other distributions. So that was done by my team, and at times coordinating with Devrim Gunduz, who's taking care of the RPM packages for Postgres. One of the things at Hygo, which I did, was an FDW for ORC file format. And at Percona, we've recently released PGStat Monitor, which is a query performance observability extension. If you need to get in touch with me, here are my contact details, my email, my LinkedIn, and the Skype handle. I more actively respond on LinkedIn these days, so feel free to get in touch with me. And if you want to reach out to Percona, you can always access our community forums. These are open forums for discussion, and you can discuss anything related to anything that we do, whether that's Postgres, MySQL, Mongo, PMM, or PGStat Monitor, or any other tool that we build. You can also check out our GitHub and see how you can contribute if you wish to do that. We are an open source company with no strings attached, so there's no kind of risk there of us closing a license or keeping that to ourselves. And feel free to share the word. The hashtag is Percona Live, so feel free to share that. Starting with some initial thoughts. So there are no really good or bad HA solutions. What there are suitable ones and unsuitable ones. And it effectively starts from understanding the needs and establishing what you really want from the application and how that application should fulfill the software as well as the business needs of the organization. So from that perspective, the number of solutions that are available out there, there's no solution that fits all different kind of needs. So this presentation is divided into 4 sections. We're going to start with some initial architectural considerations, look at some of the terminologies, before we move on to how we can manage and potentially reduce downtime for our HA setup. Before moving on to proxy and pooling, and see how we can, once an incident has occurred, how we can connect with the system then. And finally, towards the end, we're going to discuss the HA candidates. So the ones I'm going to discuss today are PgPool, PG Automatic Failover, RepMgr, and Percona. So in this first section, it's about terminologies, it's about understanding requirements, and what to consider when defining the architecture. So there are a number of architecture considerations that need to be thought and planned for. So we're just going to look at some of those. I think HA being a buzzword and everyone wants a high availability system, whether you actually need a high availability system would be the first question I'd ask somebody coming up to set up HA. In essence, HA ensures service continuity, and in an ideal world, that would mean 100% service uptime. But coming down to earth and slightly more realistic one are basically explained in terms of nines, whether that's 3 nines, 4 or 5 nines or more. 3 nines translates to, I think, more than 8 hours of downtime in a year. 4 nines is just over 50 minutes in a year, and 5 nines is just over 5 minutes, close to 6 minutes in a year. So, and when you define these nines and the uptime requirements, you're effectively also defining the entire ecosystem and the infrastructure for your setup. Because 5 minutes of downtime in a year means that uh, there would be very little human intervention for that system. So you need to have support systems that can or manage things then. Service is up and running, great, but you'd also want it to be uh, responding to client queries and in a manner that's acceptable. So you'll have certain acceptability criteria, whether that's responsiveness or whether that's load assessment, and how many connections it can handle. So it's not just service up and running, but also being able to respond in a timely and acceptable manner. Um, and whether you want to plan for that HS setup and you want to plan for the peak load that you will have in a year, or whether you want to plan for an average load, that's a that's a decision you'd have to take. But uh, you might want to have something that scales up and down based on load. So not a core requirement, but again, that can be a consideration because it translates to resources and costs. Finally, it's about recovery from failure. So there will always be that element where something can go wrong, and how do you recover from it, and how the system behaves, whether there is an automatic self-healing setup, or whether something that requires manual intervention. The moment you bring in manual intervention and hands, you're effectively compromising on your uptime criteria as well. So the first term is the recovery point objective, and that's really the effective acceptable data loss that you can have from the application perspective as well as from business perspective. Whether the system can afford a data loss of days, hours, minutes, or seconds. So nature of the application will dictate, and the business will dictate how much data loss is acceptable. So a banking solution would not want any downtime, but an internal solution, say, with uh, hosting tickets, can have data loss for internal queries and stuff. Um, what you really want is alignment with the business requirements. So that data loss should be acceptable for business, and the moment you want to reduce that time, what you're really saying is that how your application is structured. Can your application be stateful and maintain some data on its own and hold some queries and basically build up a queue, allow you to recover? What kind of infrastructure you have, how many human resources you have, and the cost implication, of course. So all of these need to be considered. Next is recovery time objective. So RPO was about data loss. This is about how much time or downtime for a service you can afford. So acceptable service downtime. So once an incident has occurred, and you want to recover from that incident, there will always be some downtime as you do the recovery. The important thing to note is that an RPO will always be followed by an RTO. However, an RTO does not necessarily follow an RPO. So it's because you don't necessarily, every time the service goes down, you don't necessarily have a data loss because, for example, the service is down as you're upgrading the setup. So there's no data loss as such, but the service is down. So recovery point objectives also need to be considered. And when you're considering this, what you really need to assess is the kind of activities that you need, time per activities, how frequent are those. In Postgres context, there is a quarterly update, so that's 4 in a year, and that's the frequency you can basically, and you can assess how much time you're going to lose. So putting this in a picture, you have recovery time objective, which happens after the incident, and recovery point objective, which is basically causes you to go back in time. As you've lost data, you're basically going back in time, so you lose that time as well. So it's like a double-edged sword with before and after kind of incident issue. So once an incident has occurred, what you really want is now, and the system is now kind of reconfigured. Perhaps you want to be able to reconnect with that system. It can be a temporary issue, say a network outage, a temporary network outage, so you can reconnect. Or it can be a bigger fatal issue where you now have another primary in the setup and you want to reroute your connections to that system. Can you do the rerouting transparently for the applications? Maybe you have a connection pooler or a load balancer that can do it. And maybe you can do a virtual IP assignment or DNS change. Other things you might want to consider are quorum size. All of these would have some kind of cost implication. So 2 or more, whether you want to have 2 systems or whether you want to have 3, whether it's an even or odd configuration. Whether the leader will be elected or selected, depending on how closely it has tracked the changes on the primary server. How do you handle network partitioning? So with 3 nodes in a cluster, you have a two-way network partition means that there will be majority in one partition and not the other one. So you can make a decision based on that. With a 2-node cluster and a 2-way network partition, it becomes very hard to then establish which one should really be the primary. And that's where the witness comes in, whether that's an implicit or an explicit witness. So you have another node that's running as a witness, whether this job can be done by your application or whether this is a separate node or whether the witness resides on the node running Postgres server itself. Can the witness node vote for itself? That's one way of enforcing that not every node votes for itself and everyone ends up with one node, one vote. So this is one possibility of avoiding that. So it's one of those strategies. And how do you avoid the split brain scenario? And once cluster has degraded. Split brain scenario happens in a single primary where you end up with more than one primary server. And that happens as a primary gets or is removed from the cluster, whether that's through a network partition or a temporary or a permanent temporary one, and it rejoins it. Which one would you trust? Maybe the new primary that has been promoted, the standby that was promoted to a primary, maybe it does not have up-to-date data. Maybe it's missing a few wall records that is not processed or they've not reached that primary. Whether you want to maintain the old primary, but you've reconfigured the network now, and there is some data, new data in the new primary that is not there in the old one. So how do you basically establish which one to go by with? Should the majority wins? Because you may have more data in the old primary than you have in the new one. How do you basically, once a node tries to rejoin the cluster, do you fence it? And that's more for the primary one. So do you isolate it and make sure that it does not rejoin it? Or does it rejoin and somebody then shoots it in the head, which effectively terminates the service? Or whether it tries to join the cluster and sees that there's already a primary node and it shoots itself in the head and it kills its process and just goes away then. So Postgres does not have a native multi-primary setup. You could argue that logical replication is in some ways, but that does not really handle data conflicts as such. So what happens in this case? What kind of network are you going to establish? How do you isolate a node from the network? If you have more than one primary, which one what kind of network topology are you going to use? Are you going to use hub and spoke model, or are you going to use mesh? A hub and spoke would be something like where you have a primary followed, which is then closely linked with a standby. And primaries are talking to one another, and standby is just talking to the primary that it's linked with. But mesh, in that case, every primary, you don't have standbys as, and primaries are talking to one another, and every primary is talking to every other primary, and you can then understand how many network connections there will be and how much data would flow across networks. So the topology matters. Again, it also depends on your application and data design. Whether your application is stateless or stateful, that also is critical if that's important. How do you minimize downtime? So I think it's really important that you start on the right foot. Preempt future needs and don't restart too quickly. And obviously, you want some of those elements to basically disruptive elements that may cause a system to hold up or block. So, is your hardware configuration planned for the next 3, 6, or 12 months? Have you accounted for how the system will grow over the next quarter or the next one after that? Have you reviewed your Postgres and OS configuration for any needs that may come up in future? Is everything tuned accordingly? Are you going to use huge pages? Are you going to disable transparent huge pages? So basically, you would want to start on the right foot at the very start. You don't want your setup to spawn your setup and then restart it just to change one guck in Postgres. And you can see what Postgres, for which configuration parameters Postgres will require a restart, and you can very simply query the PG settings table for the postmaster context, and it will show up all the settings that require a restart. So make sure you're planning for those upfront. Whether, say, you want to use PG stat statements, so do a shared preload of that upfront rather than doing it 3 months and causing a downtime after that. So once a Postgres server has crashed, do you just restart it? This is one of the things. So do you want the service to be up and running again really quickly? Simply restarting the service, maybe some other activities has happened in the meantime. It could cause an excessive load on the system. Why would it do that? Basically, it's like if you're benchmarking and you start off seeing how the benchmarking behaves. It's going to start with a very low TPS and scale significantly. In my experience, I've seen benchmarking go from 6,000 TPS to 600,000 TPS as the OS and buffer cache are loaded with the files and data, and that's 100x increase in performance in about 20 to 30 minutes. So you don't want really to start a server just because something has failed. What you really could do is either use PG core extension or PG prewarm. PG prewarm comes with the Postgres contrib modules. It's part of the core. PG core is available on GitHub. The difference between the two is that PG prewarm also basically loads the PG buffer cache as well as the OS one. Next up is rogue connections. Long-running queries are a pain, whether you're observing query performance, whether you're looking at replication and you're trying to avoid replication conflicts. Long-running queries are always a mess because they're going to hold up other activities, whether they're holding back vacuum. So that's a big pain point. So a faulty application can have a query that runs like for hours and hours, and that can basically cause your HA then to degrade. Next is obviously idle in transaction session timeout. Make sure that it's set appropriately for your needs. You can always use pgstat activity, which tells you what different backend processes are up to at this point in time. Are they waiting on something? What kind of events are they waiting on? And you can identify how active those backend processes are based on the timestamps for transaction or connection as well, and the state. Um, One of the extensions that Percona has released, which kind of helps highlight this, is um, PGStat monitor. It provides a lot of information that's beneficial, and it kind of combines um, and eases off that pain of debugging a query performance, because it not just combines PGStat monitor data, but also stat activity and auto explain. It's available on GitHub, and yes, and it's the packages are available with in Postgres Yum repository as well. So you can, if you're using RPMs, they're available there. We're working with the community to get the Debian packages available as well. And you can always use Percona's Postgres distribution, which does not has no vendor locking. So it's on disk compatible with Postgres community setup. Next, one of the things that you might want to do as your system runs and you expect it to run forever is create new indexes. Now, creating a new index would take an exclusive lock on the relation, which means that it was going to basically block any incoming request and nothing would get processed. And yeah, there's a copy paste error, so you can ignore. Yeah. So what you really want to do is you want to create index concurrently. Just plug in that concurrently keyword as you issue the create index command. That's not going to acquire an exclusive lock. You can ignore this text. This is just a copy paste error, so I'll update it. The reindex feature, it did not support concurrently until the version 12. That's when the concurrent the keyword was also introduced for reindex command. What's important to understand is that, again, long-running queries can cause an issue here. They can hold back and cause even a concurrent index creation to process and update the index, as it blocks resources. So what the concurrent index command will do is it basically becomes like a gateway for the incoming DML statements. And as a long-running query stays, it's basically going to cause concurrent index creation to build up a queue, and that obviously that build-up can cause an issue then. Finally, you would want to plan for minor upgrades because that's going to cause disruption, but also check out whether it's going to cause any issues in your environment, whether you want to test it out on a staging environment. Postgres is really good in terms of maintaining its API between minor versions. But if you're using any other extensions, that could have an issue. I've seen those issues with PostGIS in version 2.4.6 when there was with the minor version upgrade, PostGIS could not function with the newer server minor version. So that's when you also were forced to upgrade PostgreSQL along with this Postgres server. For major upgrades, whether you want to do a side-by-side installation or whether you want to spawn it on a new system, but all of these things will basically are going to feed into your uptime requirements, and so see how you want to manage these. So with all those things that we've discussed, now let's move on to proxy and load balance and connection pooling. So load balancer is not always the same as a connection pooler. And is your kernel special? Can it help in some ways, and can it do load balancing for you? And how do you make sure that you're connected to Postgres at all times? Can you even do that? So one of the ways, or a couple of ways that you can do or be transparent with the application is by either do an IP reassignment or a DNS change. An IP reassignment would mean that after a system has failed, you've assigned the IP to a new standby, which has been promoted. But what you also would want is that you want now all the systems in your network to update their MAC address binding and point it to the new the IP against that IP. So you'd issue an ARP command to make sure that they update their internal cache and make sure that the IP address now binds with the new MAC address of the new system. DNS changes are obviously another transparent way of making that change happen and making sure that the connections go to the new system. But the challenge with DNS change is that it propagates, and even with a small TTL, it can still take some time. So that remains a challenge. HAProxy was originally built as a load balancer for Linux cluster, and it has been kind of then extended for other users, including Postgres. It's a very simple, easy to install, easy to configure application, and it can connect to Postgres. So it does offer you that ability to connect with Postgres. And it does not understand Postgres. So in terms of load balancing, it does it from the outside by looking at the connections. And it offers load balancing in form of either least connections or round robin method. Now, least connections might be a good way, but you're never sure what those queries might be doing on that server. Maybe they have a lot, they require a lot of processing, and even though there are fewer connections, the load on that server can be still significant. Natively, the versions provided with your OS for HAProxy, they're pretty old. CentOS 7 has version 1.5. The latest is 2.5. And one of the things that you'll see with HAProxy, and I was surprised to see in 2.4, they had close to 1,700 commits. And those commits are obviously not just bug fixes, but there would be other feature updates and lots of other changes. So the package that is being offered natively with your distribution might be very old, and you want to.
So if I use the Quorum distribution for PostgreSQL, do I get let's say the latest supported version of HAProxy? Is it included?
Yes. So it has been included with MySQL, and we're adding it with Postgres now, and we're adding 2.5. PgBouncer is a connection pooler, so it's a very lightweight connection pooler, one of the popular ones. And it again has a very simple ini file configuration, so key value pairs, and you're good to go. It offers pool modes, 3 different types of pool modes: session, transaction, and statement. So if you have a statement, if you've configured it for a statement level pool mode, after every statement, the connection goes back to the pool, and there's a reset that gets applied to it. So you lose all the resources. For transaction, its lifespan is for a transaction rather than a statement. And then you have session level life for the connection. Default is session. And if you want to use transaction, basically you could run into issues if you're using cursors that work across transactions, or even with prepared statements, you can run into issues where the server PgBouncer would reset query resources. Though that option is configurable, it does come with the configuration parameter where you can set or force PgBouncer not to reset. And it also, you can check the pool health. Basically, it keeps an internal data structure for all its statistics, whether you want to query the pool or whether you want to query the statistics. You're basically querying the internally maintained data structure in PgBouncer. So it does not maintain it with Postgres. The output looks similar to a table format, but it comes directly from PgBouncer. It can have a tricky configuration if you're using auth query and auth user, which can go to another tool and get the user authenticated. but I think it has one issue there, which because it relies on um, hard-coded username. So it relies on PgBouncer and PG. So it creates PgBouncer and PgBouncer user and pool at the start. So those are kind of reserved, and it translates internally. So the auth query can translate those users to one of those hard-coded usernames. One of the biggest criticism for PgBouncer is that it's single-threaded. Being a connection pooler and single-threaded, so there are a lot of complaints that you hear about it. But perhaps your kernel can resolve that issue. One of the options that it supports is a SO reuse port. This option was available in Linux kernel 3.9, and it allows multiple applications to listen to the same port. And so basically, what it does is, in case of TCP, it does do load balancing at the kernel level. So you can have multiple instances of PgBouncer running, and the kernel would manage the load for you, rather than PgBouncer itself remain single-threaded. That said, kernel implementations may vary from one to another distribution, or there might be some tweaks in there, because the behavior for SO reuse port can be different. It can be load balancing, or it can be prioritization as well. So it does not always do load balancing. So do check your kernel documentation before you go ahead with this. So what we've gone through are the first three sections where we've discussed the terminologies, the requirements, basically the ability to connect. Now it's the candidates. And I'm going to discuss the open source one. These aren't really not looking at it from a perspective that they're easily configurable or installable. They're more towards like what's available out there. The first is PgPool. The reason why it's included is because it offers, as a single package on Linux, it offers a number of features. So it's not just a connection pooler, but it's also a load balancer. It understands Postgres protocol as well. So it can basically differentiate. If you've set up streaming replication and you have a single primary, it can differentiate between read and write queries as well. So it's smart in that sense. It obviously does not or cannot identify every kind of read query or every kind of write query. They have some limitations, and that's pretty well documented, but it's still reasonable. It used to have pretty bad reputation. It still has pretty bad reputation. However, one of the surveys by Enterprise DB showed that this is by far the most popular connection pooler that people are using. I think they had a survey with 3,000 customers, and most of them, I think it was probably somewhere around 35% who said that they're using PgPool. Not.
So why the bad reputation?
The bad reputation is kind of from the legacy. So it was kind of a stagnant project. It's really heavy in terms of resource consumption, because it's trying to do a lot more, not just a connection pooler, but it's doing load balancing. It's trying to understand the protocol, and I'll explain what else it does. So it's trying to do a lot more than just connection pooling. And hence, people who used it as a connection pooler did not like it, and they preferred PgBouncer, which is lightweight and does not consume a lot of resources. But a lot of progress has been done in the last 5-6 years on this project. But again, that reputation still. Then it picked up again, but it still has the reputation has not really improved as such. It supports Postgres 9.3 and above, but it's only available on Linux, so nothing available on Windows for this. It can do monitoring, and it does monitoring through Watchdog, and that's not the Linux Watchdog, but rather its own implementation of Watchdog by PgPool. It ensures Quorum presence as well, and that was introduced in version 3.5. And through Quorum presence, it can avoid the split brain scenario as well. So yeah, and it can provide one of the benefits that it has, Watchdog, is that it can then understand if any of the nodes in the cluster is failing, and it can then promote a standby to a primary in case of a primary failure. Next is Postgres automatic failover by Cluster Lab, an open license, been around for a few years now. So this project hasn't gained much attention over the past year or a couple of years now. It's pretty much stagnant in terms of GitHub stars. I think almost a year ago it had, and today it had the same number of stars, so not much. But what it is it relies on a couple of components, Pacemaker and CoroSync stack, and it also supports version 9.3 and above, and it's a Perl-based module. Specifically, so CoroSync and Pacemaker is something that's used in Linux clustering as well, and CoroSync provides you with the messaging layer, messaging and group membership layers. So it basically can tell you when a node has left the group, and that's what you really want in a high availability setup, and you can identify that now certain actions are required. Pacemaker is a resource manager, so it manages resources. So you have a messaging layer and a resource manager. PG automatic failover is a resource agent, so it knows how to assess health and do certain operations with a Postgres service. So, and being a resource agent that plugs into Pacemaker, the Pacemaker then takes responsibility and makes sure that it can do a few things. It's an open cluster framework compliant setup, which means that it's following a standard, so not just random set of things. And PF also supports that. It can manage failovers, so IP failover can be managed automatically through this. How it works is that you have to set up and create your cluster yourself. You have to configure that first. The status reporting is done through the automatic failover agent, and it's basically captured by Pacemaker, which can then assess in case of a failure whether a promotion is needed and an election is required. So one of the good things about this is that it sits outside the Postgres server, which means that it can perform server and service restarts. It can do start-stop service, and it can monitor the service. So, and it can perform failover. In case there is a timeline divergence, that's when you'd have to get manually involved and use PG Rewind to get things done. Next is Replication Manager, and looking at the GitHub stars, this is 4 times as popular as PG Automatic Failover. So it has 1.3K stars. It has a very restricted GPL version 3 license, which means that if you want to extend this, you'd have to open source your code as well. It was built by Second Quadrant, which now is Enterprise DB. And it supports version 9.5 and above fully. There were some restrictions with 9.3 and 9.4. What it provides is it comes up with a couple of utilities. It basically helps and eases the setup process and configuration process, and it also provides monitoring of the cluster. So the 2 utilities that comes up with is RepMgr, which is a command line utility. And you can basically use that to promote a server or set up a new one, a standby, or you can monitor the cluster using that command line utility. And as if you want to set up a new server, standby server, that's where you need the SSH, the rsync as well, because you want to take a backup and transfer it on the new system using rsync, and hence the dependency on rsync here. RepMgr D is the daemon that runs and that can send out notifications based on user scripts. So once an event has been detected, RepMgr has those extensions where you can add your own scripts. Um, so one of the tricky things about RepMgr is that it needs to be part of shared preload library. So that means that it's basically very strictly tied with the Postgres server itself, and it's part of the Postgres server. It creates its own schema, and that schema is maintained, and that data is maintained in Postgres server. For promotion, since for promotion it requires a passwordless entry to that system, which means that if you want to, and in some cases you don't really want to open up that additional port across systems. One of the things in configuration that it relies on is location. So when you're configuring RepMgr, you're basically specifying a location, and that location tells you, or basically defines kind of a data center concept, which means that when a primary fails, it can only have a failover to one of the standbys that share the same location value. And if there are none, then you would not have a primary in your setup then. And that's when you basically would get involved and manually. It cannot do a restart and stop service. Remember that it's part of the Postgres itself. Hence, it cannot really start a service if it's not started already. Finally, the most popular one that's out there, and that's Percona. Percona has a very open license. It's an MIT license, and in almost 7 years now, it has gained significant traction, almost 5,000 stars on GitHub. And that's looking at the other solutions that are available out there. That's almost 3.5 times better than the second placed HA solution, which is the RepMgr. And when I say second placed, this is not based on the GitHub stars, but rather the State of Postgres survey by Timescale DB in 2021, which put Percona as number one and RepMgr as the second most popular high availability solution. And then there were others, but all of these are got single digit percentages in their survey. So what this is, it's really a bootstrapping framework. So it's not a solution. It's not a one-click installer that you can just deploy and get started with. It requires on a number of tools. So it combines things together to build up an HA environment. For configuration, it depends on the YAML file. Then for connection with Postgres, it requires with the Python connector psychopg2, which means that you require Python. It requires a distributed configuration system. The most common one or most popular one is etcd. And in some cases, you might hear the request for Zookeeper as well. And it's built in Python. So you have a number of dependencies here. For monitoring, it depends on watchdog. That's the Linux watchdog, not the PgPool one. And for load balancing, you have HAProxy then. Percona started off, and its origins trace back to the Governor project by Compost. So that was the original HA framework for Postgres. So they provided the template for Postgres high availability. But that project has been now archived on GitHub and is no longer being maintained. So this got forked out of that, and it effectively relies on a distributed configuration system. So it does not do any kind of maintenance of data itself, but rather it relies on an external tool, which is a pretty decent decision because in some cases you may already be using one. So it's a template. It's not really a solution. It's a template that requires you to go through configuration. It takes time, and some people will tell you that it's really complex. But you can find resources. Being this popular, recently Percona also created a document on how you can set up Percona in your environment. You would have to configure psychopg2 and whatever DCS you are using, HAProxy and Watchdog. So how this works? So basically, the DCS maintains the leader lock, and that's what ensures that you can only have one primary in the setup. The leader lock is maintained, and for any node to become primary, they need to acquire that leader lock and they need to maintain it. And based on the configuration, say, I think etcd has a 30-second expiry TTL of that leader lock, which means that that node has to renew that lock every 30 seconds. Failure to do so would mean that there is an issue with the primary node and it needs to then maybe initiate elections. So that's how it avoids the split brain. Again, it has trigger scripts where you can user can write their own scripts for notification and other actions. So as the performance or as the system gets degraded, there is a way of you being notified. So just to recap what we've discussed some uptime criteria, we've discussed RPO and RTO. We've gone through how we can connect, whether that's through IP or DNS or other means. Load balancing and connection pooler is what we've discussed as well. And we've also discussed some of the options that are available out there. A couple of options that are not captured in this presentation. One is Stolon and the other one is PG auto failover, which hopefully in the next version I'll add as part of this discussion. Just the Percona values. So we want our software to remain open, and we want people to trust that it's basically available for everyone's use. So no closed sourcing, and it's very open. Everything that we do is open source, whether that's PGSat Monitor or even our packaging that's part of that open source repositories. And we want you to maintain your freedom if you pick up any of the tools that you from Percona. Thank you so much. Let me know if you have any questions.